Okay, so in this section, section 8, we're going to learn about isosceles and equilateral triangles. Again, you can use the definition of isosceles and the definition of equilateral as a reason and a proof. So understand what makes a triangle isosceles and equilateral as we go through this lesson. Okay, so this first slide is the vocab. Okay, you need to know the parts of an isosceles triangle. So the vocabulary is going to be important to you. So the first thing we're going to see here is this vertex angle. This vertex angle is where the two legs meet. And then we have the two sides of the triangle. They're called the legs. And both of these sides in an isosceles triangle, or both of these legs, are going to be the congruent sides. The base is going to be the non-congruent side. It's going to be different. And then the two base angles are also going to be congruent angles. Okay, so know which sides are called the legs, which one is called the base, which one is the vertex angle and the base angles. The base angles are the congruent ones. The vertex angle is the non-congruent one. It'll be different. Any questions on this vocab? All right, let's go to the next slide. Okay, so here is our first theorem of this lesson. It's called the base angles theorem. And what it states that is if two sides of a triangle are congruent, then the angles opposite them are congruent. So what this tells me is my base angles down here are going to be congruent if the sides opposite them are congruent. So notice angle B is opposite side AC. So angle B is opposite side AC. And angle C is opposite side AB. So because we have these two congruency marks here, this tells me that the two base angles are also congruent. So when you have two congruent sides, then the angles opposite them are also congruent. Now we're going to have the converse of the base angles theorem. So this says if the two angles of a triangle are congruent, then the sides opposite those angles are congruent. So they're flipping it around. So now they're going to start with the angles being congruent, and we can state that the sides opposite them are congruent. So this side over here is opposite the B, and then C would be here, so we could say that those two sides are congruent. So the converse of the base angles theorem. When you have the test, you're going to apply them. I'm not going to ask you to restate any theorems or postulates. If you use this as a reason in your proof, you can call it the converse of the base angles theorem. If you forget the name of it, just rewrite it. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. If you ever forget the name of a theorem or a postulate. Everybody good? All right, next slide. Two corollaries to the base angles theorem and the converse. So if a triangle is equilateral, then it's equiangular. And then the converse to that, if it's equiangular, then it's equilateral. So you've already realized this, but now it's officially presented to you as a corollary. So the corollary to the base angles theorem, if a triangle is equilateral, then it's equiangular. And then the corollary to the converse of the base angles, if it's equiangular, then it's equilateral. All right, so now here's the application of what we've just learned. Notice now also one thing I want to point out is when your variables or your expressions are inside the triangle, they're referring to an angle measure. So in this particular problem A, the x is inside, so it's looking for one of these base angles, because notice the congruency marks here on the side. This is telling me that these two sides are congruent. telling me it's an isosceles triangle, so I can also state my base angles are also congruent. So this is an angle measure I'm looking for. What would be one way I could go about figuring out what x is? Any suggestions? Hayden?
30 plus x equals 180.
Do that again. Say that again.
30 plus x equals 180.
Okay. How many angles are in a triangle, though? 3, right? So what if I did x plus x, because this other base angle is also x, then plus 30 equals 180. I could write out a whole equation. Everybody with me on that? So then I would get 2x plus 30 equals 180. Subtract the 30. 2x equals 150. Divide by 2, and x equals 75. Now, without writing an equation, I could have realized that, okay, all 3 angles need to be 180. I could minus the 30, get 150, and then divide that by 2, which is the same thing I did when I set up my equation. Okay, so on the test, I don't necessarily need to see the equation. It sometimes helps, but you could have also just shown all of this work here, subtract the 30, and then divide by 2. All right, now on B, this one, it's side lengths I'm looking for. Tessie.
You can do 2x minus 4 equals x plus 5.
Beautiful. So here we're going to realize that these two sides are congruent, so I'm just going to set up the 2x minus 4 equals x plus 5. This one I need an equation to solve. So then I'm going to subtract the x and get x minus 4 equals 5, then add the 4, and x equals 9. Be careful because sometimes I see a lot of students get confused. They're thinking I'm looking for angle measures, but those expressions were outside. Common mistake would have been doing 2x plus 2 plus 2x minus 4.
Can you please restate your attendance? I haven't received it.
Okay.
Thanks.
Okay, so that was the answer to C. It was 42. All right, let's go on to the next slide. And we have a proof. However, they've given us the stuff. We just have to put it in the correct order. So let's start out. This is our given and our proof. So here's our statements. And here's our reasons. So what's going to be statement number 1? The given, all right, which was angle 1 is congruent to angle 2. So this was letter D. And then over here it's given. Okay. Next statement, what's it going to be? Which one? A, B, or C? Obviously, C is going to be the last statement, right? Because that's what we're trying to prove. B, you said? Okay. So we're going to put in B. What is the reason for B? What kind of angles are those? Good. And that's going to be our reason. We have 2 vertical angle pairs. Now, if you were writing your own proof, you could have turned this into 2 statements if you wanted to. But they both have the reason of vertical angles. All right, so we've used D, we've used B, and we already know that C is the last one. So we know our next statement is going to be A, which is 3 is congruent to 4. What's going to be our reason on this one? Now, it's going to be substitution, and when we do substitution, we can do it in 1 step. If you wanted to do transitive, you would have had to do it in 2 steps. So this reason is going to be substitution. And then the last one is going to be OK is congruent to OJ. And that reason is transitive. I'm sorry, base angles converse. Base angles converse.
We're gonna use D. Oh, never mind.
Okay, everybody good? There you go, there's 7. All right, so your homework is the practice B. It's due tomorrow morning. You need to turn it in. I haven't looked at it yet, so I'm not sure what's on it. Tomorrow we will review for the test. So I should have it narrowed down to exactly where we can focus on what's on the test. Again, at least 2 proofs. So be ready for to write an entire proof yourself. Any questions on this? How many proofs? Another proof. Now, this is a little typo here. This should say measure angle 1 equals measure angle 2. So you can fix that. Little typo there. Okay, so it said M is the midpoint of AB. What does a midpoint do? When it's a midpoint of a segment, Mary Angel? Okay, cuts it in half into 2 congruent pieces. So already I can see that this is congruent, AM is congruent to MB. Okay, and that's going to be a statement in my proof. Also, let's see, it said the measure of angle 1 was congruent to the measure of angle 2. So these 2 are congruent. So let's go ahead and start our proof. We've labeled our picture. They want us to try to prove that AC is congruent to MB. So first one, statements and reasons. First statement's going to be what? Good. M is the midpoint of AB. Okay, don't ever leave this given off your proof. You're leaving points behind. So M is midpoint. I didn't write that in there. Midpoint AB. Okay, then we're also going to state, well, we could actually put now what the midpoint does. Why don't we do that first before we state the other given? So I can now show that AM is congruent to PM or MB. And this is definition of midpoint. Now, what am I going to do next? I can put in my given, right? Measure of angle 1. So angle 1 congruent to angle 2. Given. Now what? Tessie.
You can say, since the 2 angles are congruent, that means the 2 legs are perpendicular.
Perfect. Okay, we're going to do the base angles converse. So we could say that AC is congruent to AM because the base angles converse, or the converse of the base angles. Okay, so if the angles are congruent, that means the sides or the legs are congruent. And then now lastly, Tessie?
And can be transitive.
Perfect. And we're going to do, our last statement is going to be transitive, which was what we were trying to prove, that AC is congruent to MB by the transitive property. Perfect. Very nice. Of the notes, yes. Okay. You can ignore the last slide. That was from a different class. So that is the